Hi, welcome to the mathcenter.com. In this video, we are going to solve a problem in further mathematics, further maths, so to speak, the CIE syllabus. Okay, we are looking at the question on the board. I'll go through the question in a minute, but let me tell you, this question is found in the further maths paper 1 CIE exams, the recent exams, October, November 2015. Okay, again, the further maths paper 1, the CIE exams, October, November 2015. Subject code is 9231/11. This question is number 1 on the exam paper and it's worth 4 points. Okay, do it well and you get a great start in the exams. So let's start. You're given x equals to 2 cos cube t, y equals to 2 sine cube t, a set of parametric equations. T is between 0 and pi over 2. We have to show that the second order derivative d2y dx squared is something 1 over 6 second to the power 4t cosecant t. So let's start slowly. Let me start with y. Okay, y equals to 2 sine cube t. So first off, let's go ahead and find dy dt. Okay, I'm leaving the 2 as it is. I'm going to differentiate sine cube t. So bring the 3 down, reduce the power by 1, and then you forget the power and you differentiate sine t, you will get cos t. Again, I've left the 2 alone and I've differentiated sine cube t. I brought the 3 down, I've reduced the power by 1, sine squared t, and then you forget the power and just differentiate sine t, and you will get cos t. So here we will get 2 times 3 is 6 sine squared t cos t. Okay, 6 sine squared t cos t. So I'm going to write it here and erase the board. So dy dt equals to 6 sine squared t cos t. Okay, good. Now let's take care of x. Okay, let's take care of x. X is given as 2 cos cube t. Same method we are going to use. Okay, differentiation, dx dt. Okay, the 2 I'm leaving it alone. Differentiate cos cube t. Same method, bring the power down, reduce the power by 1. Then you forget the power, differentiate cos t, you will get minus sine t. So let me write the answer here. Dx dt will be equals to 2 times 3, 6. There's a minus here. Let me write the minus in front. Okay. So I'll have minus 6 cos squared t sine t. Okay. So I have minus 6 cos squared t sine t. And we are done with that part. So now let's use the results that we have just found. So let's write down dy dx first. We are going to find d2y dx squared. So we have to write down dy dx first. So dy dx equals dy dt times dt dx. Again, dy dt times dt dx. This is a chain rule. So let's write it down. Dy dt will be 6 sine squared t cos t. Got it? It's from here. 6 sine squared t cos t is dt dx. This is what? This is dx dt. So let's invert it. Okay? Again, be careful. This is dx dt. What we have here is dt dx. So just invert it. I have 1 over negative 6 cos squared t sine t. Let's clean this up a little bit, yeah? So this 6 and this 6 is gone. So I'm going to leave my negative here. Okay? Again, this 6 and this 6, we'll cancel it. There's a negative here. That's the negative that you see here. Let's clean this up. I have got sine squared here and I have sine here. So let me cancel this. So I'll have sine t. Okay. And then I have a cos t here and a cos squared t here. So let me cancel this. And I'll have a cos t at the bottom. So dy dx is equals to minus tangent t. Okay. So do this carefully. Sine squared and sine, cancel this. You're left with one sine here at the top in the numerator. This is cos and this is cos squared. Cancel one of those. You have a cos t in the denominator. Don't forget the negative. So negative sine t over cos t, you'll get negative tangent t. Okay, now let's go to the next step. So let me write it here and let's keep our answers. Negative tangent t. Okay, so we're going for d2y dx squared. So let's do that. Okay, good. Let's start with the line that we just had. Okay. To get d2y dx squared, we differentiate dy dx again with respect to x. So I have d2y dx squared. We have to do implicit differentiation again. So I have got tangent t. If I differentiate this, I'll get minus secant squared t dt dx. Okay? We are doing implicit differentiation. Don't forget, we are differentiating with respect to x. So this becomes d2y dx squared, and this one becomes negative secant squared t dt dx. Okay? If you have forgotten this, just remember last time when we did implicit differentiation. Okay? If you have to differentiate y squared, you normally write the 2y and then multiply that by 2y times dy dx. Same idea. We have secant squared t times dt dx. Okay, good. So now let's continue. We have minus secant squared t. What is dt dx? Oh, we have it here. Okay, we have that here. And let's write that down. 1 over negative 6 cos squared t sine t. Okay, so I have a negative here and I have a negative here, so that disappears. Okay, and then I have a secant squared t and I have a cos squared t at the bottom. So I bring the cos squared t up, I'll get, excuse me, let me write the 1 over 6 first. Remember there's a 6 here, so I have 1 over 6. 1 over cos squared is secant squared. Secant squared times secant squared is secant to the power of 4t. And 1 over sine t is cosecant t. There you have it, d2y dx squared, 1 over 6 secant to the power of 4t times cosecant t. And we are done.